Usage and debugging of AC105 platinum resistance temperature collector. The following will be explained in 5 parts. 1. Hardware introduction and preparation. 2. Software introduction and preparation. 3. Actual operation introduction. 4. Access system explanation. 5. Common problem troubleshooting. Before debugging, first, let's understand the working principle and data flow of the platinum resistance temperature collector. The platinum resistance sensor converts temperature variations into resistance signals, which are processed by the device into digital temperature values and transmitted to the cloud server via Cat1 wireless network. When the server receives alarm signals, it notifies administrators via SMS or phone calls to enable timely response and prevent unnecessary property losses. 1. Hardware introduction and preparation. Required hardware equipment. Before operation, our company provided hardware includes platinum resistance, temperature collector, 4G antenna, configuration cable, customer prepared items, a computer, platinum resistance sensor, hardware connection, demonstration. First, connect the 4G antenna. Screw the 4G antenna onto the host's SMA interface. Position it vertically upward. Then connect the platinum resistance sensor. For 4-wire platinum resistance sensors, connect the 2 red leads from the sensor to the red and black terminals on the device respectively. The 2 white leads can be connected to the remaining 2 terminals. For 3-wire type, connect the 2 red leads from the sensor to the red and black terminals on the device. The single white lead should be connected to both remaining terminals. Then connect the wired sensor to the host device. To configure sensor parameters, connect the configuration cable. The red LED will stay on. Plug the USB end into a computer. Turn on the power switch. The green LED will stay lit. Now parameters can be configured. During configuration, the green LED should be steady or blinking. If the green LED turns off during configuration, this indicates the device entered sleep mode. Turn off the power switch and restart after 5 seconds. The green LED will relight. Alternatively, unplug and replug the cable. Close the software serial port. Before unplugging, reselect the serial port. After reconnection, after reinsertion, the green LED will blink. Configuration can continue. 2. Software introduction and preparation. Contact support for configuration software. Open the downloaded configuration software. Find the serial port driver. Find this application and click. Keep clicking next to complete installation. The subsequent steps will not be demonstrated. The serial port can be emulated via the configuration cable. Right-click this PC. Click Manage Device Manager Ports to check if the serial port driver is installed. Serial port selection and parameter configuration. Open the configuration tool. Select the emulated serial port. Open the serial port. Now configure sensor parameters. This is the IP configuration section. First, select network type. We'll demonstrate TCP connection. Select TCP. Configure cloud server IP and port. Domain name can be used instead of IP, since domain names take priority. When not using domain login, leave the domain field blank. After configuration, the collector will send data to the specified server. This is the MQTT parameters section. No configuration needed here. Next is general parameters. Device address uses 4-byte programmable ID as specified in the protocol. Configurable by user. Upload cycle, duration between heartbeat packets to server. For online status confirmation, configurable. Unit, minutes. Longer intervals conserve more power. Receive time is the maximum wait time. For server response after connection. Unit, seconds. During this 5-second window, remote configuration of alarm, conditions or intervals is possible. See Section 3 of the AC-105 manual for command formats. Server command format in TCP protocol. If no response is detected, the device enters sleep mode. Registration packet can be customized, sent before establishing communication. As an initial handshake, alarm reporting interval is the frequency for repeated alarm transmissions. Unit, minutes. Sensor type should match your hardware. Alarm condition settings. Configure high or low temperature thresholds. Then select the alarm mode according to temperature requirements. Select from 4 intelligent alarm modes to cover various monitoring needs. Temperature compensation corrects measurement deviations. Place sensor in known temperature environment. Record deviation between measured or actual values to determine compensation value. Parameter display section shows version number and SIM card info. This is the APN configuration section. Fill in the APN scenario correctly based on the SIM's carrier and card type. For the specific name, please consult your carrier. Enter the APN username and password as required by the carrier. For IAT cards, these fields are usually left blank, while regular cards may require credentials provided by the carrier. Once filled in, save the configuration to apply. Click Write and reset. Configuration is now complete. 3. Actual operation. Introduction. After configuration, when connected to cloud server, the monitoring interface will display sensor status information, including device status, battery level, temperature readings, reporting interval, etc. Current status shows normal. Now we'll simulate overheating with hot water. Alarm threshold is set at 45 C. Triggered when threshold. Using 70 C hot water. When immersing the sensor, alarm activates. Data transmits to server. Configure voice or SIMS alerts via triggers. Set trigger condition to value equals 1 to 9. Then select contacts. When activated, the server processes alarms and delivers alerts via voice calls and SMS to designated personnel.
铂电阻温度采集6号下面的传感器设备状态，触发报警数值等于129报警，请登录平台查看详情。
Enabling rapid response to minimize losses. 4. Access system explanation. To integrate with customer servers, configure the server IP and port in the collector. Once configured, the server acts as TCP server to receive collector data. Note that this is a low-power device, acting as client, not permanently connected, only connects during data transmission, disconnects and sleeps afterward. Data format is hexadecimal. See Section 5. Communication Protocol. In the AC-105 manual, the above uses TCP connection. MQTT protocol is also supported. 5. Common problem troubleshooting. Unstable temperature readings. Check for loose or oxidized terminals causing poor contact. Ensure secure connections. Keep cables away from high interference sources like motors or frequency converters. No data received. Verify server IP or port configuration. Check for SIM card issues, depleted data or weak signal. Contact our support if local for grams coverage is unstable. Relocate the device. Serial port not detected. Ensure cable is securely connected. Try different USB ports. Cables. Check port status in device manager. If abnormal, reinstall serial port drivers. This concludes the AC-105 setup and debugging process.